The $60 billion IDE. SpaceX just paid $60 billion to acquire Cursor, the largest acquisition in aerospace history for a software company that does not build flight hardware. This move signals a pivot from simply purchasing compute to owning the specific interface where human engineering intent is translated into machine code. While the valuation seems inflated for a code editor, the price reflects the proprietary indexing architecture that allows Cursor to map entire codebases into a high-dimensional state space that generic models cannot replicate. Why contextual indexing wins? Cursor succeeds where other agents fail because of its custom implementation of shadowed edits and repository-wide RAG. Unlike standard wrappers that send snippets to an API, Cursor maintains a local, constantly updated graph of every dependency in a project. For SpaceX, this is critical. When you are managing 20 million lines of C++ across the Starlink constellation, a generic large language model misses the downstream effects of a single variable change. Cursor's backend predicts these collisions by treating the entire repository as a single, searchable token space. This technical mode is what prevents the hardware-software loop from bottlenecking during rapid Starship iterations. Managing the constellation scale. The skepticism around this deal centers on the price tag, but the telemetry data from Starlink v4 explains the urgency. The constellation now handles more edge case software interrupts per second than a human team can manually debug. SpaceX is effectively betting that an agentic editor can maintain flight software more reliably than a scaling team of engineers who can no longer track global system dependencies in their heads. By integrating the editor directly into their hardware testing silos, they are creating a closed feedback loop where the AI identifies a failure in the simulation and suggests the fix in the IDE before a human even opens the ticket. The logic of vertical integration. The acquisition of Cursor demonstrates that in high-stakes engineering, the optimized environment is now more valuable than the underlying model. By controlling the IDE, SpaceX captures the proprietary training data of how their top engineers solve hardware-software conflicts in real time, effectively digitizing their internal expertise. This move transforms the developer environment from a tool into a data moat that reinforces SpaceX's lead in launch frequency. We are seeing the end of the general-purpose developer and the rise of the vertically integrated agentic workflow. The metric to watch now is the delta in deployment velocity between SpaceX and traditional defense contractors who are still relying on fragmented, third-party software stacks. If the time to patch for orbital hardware drops by even 30%, the $60 billion price tag will be seen as a calculated efficiency play rather than a speculative bubble. Subscribe for more.